In this lesson, we're going to go over writing our two-step equations. We've mastered solving them, and because we've had that exposure to what they look like and how we can move them around, it's going to be a lot easier to create them or write them on our own because we know what parts we should see when we are writing the equations. We're going to start out with a tiny little word problem at the top here about Melody, so follow along with me. It says Melody has a new job recording for the All-Time Favorites record label. She's paid a monthly base salary of $4,850. She gets $3 additional, so plus $3 for each CD sold. And you can tell the datedness of your Springboard book. This is taken from your Springboard book, and I don't think they realize that you guys do not buy CDs. That's how we used to get our music. Everything you do is streaming. So the first job we have is to complete the table. And the table follows a pattern. It's nothing too difficult to decipher. So if you look on the left-hand side, we've got the number of CDs sold. Then the expression to find her income, and income just means how much money she's making. And then her final total income once we evaluate the expression. So we started out, if she doesn't sell any CDs, she's going to get the $4,850 base salary. That's a given. She gets that every single month. But she is not going to get any additional money because she wouldn't get that $3 extra for selling a CD. She sold none. So that just is her base salary of $4,850. For the next one, if she sold one CD, well, that's her base salary. That's a given, plus $3 times one CD. That turns into $4,853. Two CDs, base salary, $3 times two CDs. That is a total salary of $4,856 this time. So hopefully you can follow that pattern. If she sold 3 CDs, again, she's got her base salary coming to her, and this time we're doing $3 times the 3 CDs she sold. So that would be a total of $4,859. 4 CDs, $4,850 base salary plus $3 times 4 CDs. That's $4,862 that she's making. And then last but not least, 5 CDs, so her $4,850 base salary that she gets no matter what, plus $3 for each of the 5 CDs that she sold. And that would be a total of $4,865. So now we're going to take a look at our table and notice some patterns. What are the things that you're noticing every single time? Well, hopefully you're noticing that $4,850 every single time included in our expression. No matter how many CDs she sold, she's getting her base salary. And hopefully you're noticing that that 3 exists in every one of our expressions, and the only thing changing is what we're multiplying it by. Noticing these patterns is really helpful when we're trying to come up with the parts of the equations that we're going to be writing. So I want you to try and link the patterns that we just mentioned to the vocabulary that we use in our expressions and our equations. So down at the bottom, I've got some vocabulary listed here. The first one is constant. Now think back, what is a constant? Remember, a constant is that number that is all by itself. It never changes. It remains constant or the same always in an expression or now in an equation. So what could we call our constant from our situation with Melody? Hopefully you are thinking that 4,850, that's pretty constant. It never changed. She gets that base salary in every single scenario. The next one I want you to think about is coefficient. So remember, our coefficient is the number in front of the variable, or the number that's being multiplied times our variable. Is there something that we are multiplying by every single time? And hopefully you're noticing, yep, it's the 3. That 3 is the coefficient. The last thing we're going to think about before we move on is, of course, we're always going to have a variable. We're working with equations. So what would our variable represent? Remember, our variable is called a variable because it can change. If I look at my situation, what changed every single time? This 0, then 1, then we used a 2, then a 3, and those numbers represent the number of CDs sold. We've got in the first column here. So 0 CDs, we multiply 3 times 0. 1 CD, 3 times 1. So our variable can change, and we always need to make sure we recognize what exactly variable are we going to use and what does that variable represent. Well, in our case, our variable, we'll say we're going to use an x, and that x is going to represent the number of CDs sold. Now we're going to also need a total, because if we're working with an equation, we're going to have an equal sign. So that means we're going to have a right side of our equation where it gives us the total amount after we evaluate the left side. As long as you can identify all of these parts, the constant, the coefficient, the variable, and then the total amount that's going to be by itself on the right or the left side, you can easily write an equation. So we're going to try that out. We're going to look at a couple situations here, read them, identify the parts, and then create an equation using those parts. So for the first one, read along with me and think about what the number values are representing in our situation. It says the members of a Taekwondo class are ordering jackets. Each jacket costs $35. That's each jacket. And there is a one-time fee of $25 for the design. So our job is to write an equation to represent the number of jackets N that were ordered if the total cost is $620. Well, do we have a constant? Do we have a number that is staying the same every single time? And hopefully you are saying yes. No matter how many jackets we buy, we have that one-time fee of $25. So that is our constant. It will never change. The Taekwondo class will always be charged $25 first. And then we have a coefficient that's going to be multiplied every single time, and that is our $35. And that $35 is getting multiplied times our jackets. So we're using N to represent our number of jackets. And the total amount that all of that is going to cost is $620. So when we're ready to write our equation, remember the form that we usually see our equation. We usually see our coefficient and our variable. So that would be 35N. And I just took that from my coefficient and my variable. Next, we see our constant being added or subtracted. In this case, unfortunately, it's costing us, so we're going to add on that constant. And then last but not least, we have our equals total of 620. So let's go a little faster down here. A stockbroker charges his customers $30 to open an account and $50 per month. Hopefully that word per is kind of sticking out to you as meaning every single month over and over again we're going to be charged $15. We're going to write our equation to represent the number of months using N as our variable. An account has been open if it costs $360 in total. So I'm going to actually first start with my variable. I know I'm using an N, and I know that's going to represent the number of months going by. So I've got to figure out what number, 30 or 15, is my constant. Does it never change? Well, hopefully you're seeing that 30. The 30 is to open the account. Anybody that walks in pays that flat $30 no matter what. It will not change. But what will change is the coefficient of 15 because that's going to change per month. And our total, $360. So when we write our equation, remember we need our coefficient and our variable. So our coefficient of 15 times our variable n, so $15 times every month, plus the $30 constant, or the $30 to open the account, we need it to equal $360.